Okay, let's do this key real quick. Right here, when you're talking about in behavior, because this is even, I know that they're going to either go both up typically, okay, when it's even, but because it's negative, it will do the opposite of that. So they're going to both go down, okay? So it's going to go down on the left, there it is, and down on the right. So this should have been this. Okay, notice this is odd. So typically, this looks like this. You know, if you were going to think about x to the third, it looks like this. So it's going to go down on the left and up on the right. And it is still positive, so that's good. So down on the left, up on the right. So that should be that one. Okay, on this one, your zeros. And I didn't ask the multiplicities here. Some of you went ahead and gave them to me, and I can't honestly remember if I do that on the test. But if you have an x out front, 0 is a 0. And if you're talking about multiplicity, you would say it had a multiplicity of 2. Okay, 3 is a 0. And you can see why, because if you put a 3 in there, it would give you 0. And then so is negative 2. And negative 2, well, you would say it had a multiplicity of 2 as well, whereas 3 has a multiplicity of 1. I didn't ask that, so it wasn't absolutely necessary. Okay, to find your y-intercept, you simply plug in 0 everywhere you see an x. I'm actually going to quit here because when I plug in a 0 and I square it, I get 0. 0 times, I don't even care what else I get 0. And by the way, if 0 is a 0, it's also one of your y-intercepts. It is the y-intercept. Okay, your degree here. Now, right here, your degree is 4 because it's written as a polynomial. This is factored out. So the way you have to find your degree is you have to add these up. So this would be 1, 2, 3, 4, 5. So my degree is 5. All right. Now, when you get ready to graph this, zeros are your x-intercepts. So let's go ahead and graph that. So I have 1 here. I have a 3. And I have a negative 2. And then I go ahead and I put in my in behavior. Since this is an odd degree and negative, okay? Remember up here when it was an odd degree and positive, it looked like this. So it's negative, it's going to be the opposite of that. So it's going to go up on this side, and it's going to go down on this side. Okay, so you already have several points here when I'm graphing it because I'm looking at your in behavior. Now, does it bounce anywhere? And so I'm looking, if it has an even degree, it's going to bounce. So it's going to bounce at negative 2. See at that 0 how it has an even exponent? So at negative 2, instead of crossing, it's going to come up here, and I'm looking through my phone, so this may not be real neat, but it's just going to come up. Let me see if I can do this. It's just going to kind of bounce right off. It's not a sharp V, it's a smooth curve. Okay? Now it has to come here and hit. And I don't know how high it goes, and I really don't care, okay? We're just tracing this, so I'm going to come down and I'm going to make a smooth curve to hit this 0. Make sure, I mean, some of you were on top of this line, you came up here, and then you came right down on top of the y-axis. You can't do that, okay? It only hits at this one point. All right, then at 0, it also bounces because there's an even exponent. So I'm going to come right here, and I'm going to bounce right off like that. And then it crosses at 3. Because this is an odd exponent, it's an exponent of 1 if you don't see it, I know it's going to cross. Now, I didn't ask, I don't care how high it goes. If you're looking in a graphing calculator, maybe it goes high, I don't know. I'm just looking for something nice and smooth. So you were graded on did you know your zeros, did you know your in behavior, and did you realize that it bounced at negative 2, it bounced at 0, and it crossed at 3. That's what you were graded on right there, okay? So let's do this again. What makes this guy 0? 1. Had I asked for multiplicity, I would say I had a multiplicity of 3. What makes this guy 0? Negative 2, with a multiplicity of 2 had I asked. What makes this guy 0? 4. Those are your x-intercepts. So if you wanted to, you could go ahead and graph those. So there's 1. What was my other one? Negative 2 and 4. Negative 2 and then 4. Okay, like that. Your y-intercept is everywhere you see a y, you're going to have to plug in, an x, you're going to have to plug in a 0. So 0 minus 1 is negative 1, and when you cube it, you get negative 1. Okay, put in a 0 here, and you get 2, and you square it, you get 4. Put a 0 in here, and you get negative 4. 2 negatives give you a positive, so it's going to be a positive 16, okay? And then your degree is 3, 4, 5, 6. So it has a degree of 6. Okay? So let's think about your in behavior. This has an even degree. So because it's an even degree, remember we talked up here, if it had an even degree, how they both go up? So they're going to both go up because this is positive. Had it been negative out front, they would have both gone down. So I just go ahead and I do that. You know, I know this is going to go up. So it's going to look something like this. I take the furthest point on the left and I go up. Take the furthest point on the right and I go up. Now, does it bounce anywhere? So this is how I decide. You see any of the exponents that are even, and I'm like, yeah, right here it's even. So that means it's going to bounce at -2. And that will be the only place it bounces. And by the way, let's stick in my y-intercept. My y-intercept is somewhere, it's way up here, but I'm just going to label this 16. It's off the graph, okay? So here's what I'm going to do. I'm going to bounce off, and remember, I'm kind of looking through my phone, so this is not the best. But I'm going to bounce off. I'm going to come up here and hit my y-intercept, and then everywhere else it crosses. Now, I don't know how low it goes, and I really, again, I don't care. This is a rough sketch, so this is good enough. If you left it like this, some of you left these big holes in here, like this, because your graphing calculator showed you this. I took off. Your graph has to be smooth and continuous with no sharp turns, and it can have no holes, all right? So that's page 1. Let's go to page 2. Okay. It says, determine whether the leading coefficient is positive or negative based on the in behavior. Okay, and, excuse me, I didn't finish that, if the degree is even or odd. Well, do you see how both sides are pointing up? That tells me it has to be even, okay? Remember, if it's even, they either both point up or they both point down. They do the same thing. So it has to be even, and since they're both pointing up, it has to be positive. Okay, it says approximate the real zeros of the function and determine if their multiplicities are even or odd. So let's look at this first one. My first 0, let me zoom in right here, looks like it's a -2. And you see how it crosses? That means that my 0 at -2, it has to be odd because it crosses. Okay? My next 0 is at 0. And do you see how it bounces? It doesn't cross here, but it touches 0 and then bounces right off. So it has to be even, because remember, if it has an even degree or an even multiplicity, it bounces at that 0. And my last 0 is 2, and it crosses here, so it has to be odd. So you have to be very specific on this, okay? This says 3. It was actually worth 6 points right there, because I did it like this. 1, 2, 3, 4, 5, 6. Find a polynomial for the graph and leave your answer in factored form. Okay, remember, if this is a 0, then here is a factor. Because think about it. If you plug in -2, do you see how you get 0? If 2 is a 0, then x minus 2 is a factor. And you can see that if you plug a 2 in here. If 0 is a 0, then you can just stick it out front. And because it has to be even, I just squared it. And you can see that this has a degree of 1, 2, 3, 4, which this had to have at least a degree of 4. So there's that one. All right. Use synthetic division to divide this polynomial. Okay, here's what happened. First of all, some of you didn't see the fact that this is missing the x squared term. So when you do synthetic division, make sure when you write down all your coefficients, you have to put in this placeholder for x to the second, or it doesn't work. So there's x to the first, and then there's my constant. If this is to the 4th power, you should have 5 numbers written down right here. And then you want to make sure when you do synthetic division that you use what makes this 0, which would be -1. Okay. I'm looking through my phone, that's so weak. When you drop this, drop whatever this number is. So it's going to be a 2, so drop it straight down. Multiply on the diagonal, and then add up and down. Multiply on the diagonal, and you add up and down, just over and over again. So that gives me 2, that gives me -2, so I have a remainder of 3. Now look what it says. Rewrite your quotient in correct form, including the remainder if there is one. So here's what I'm looking for. If this is x to the 4th, then this first term will be x to the 3rd. So you should have written 2x to the 3rd plus 5x squared minus 5x plus 2. And the way you write your remainder is 3 over whatever your divisor was, x plus 1. Okay, that's the way you had to write it to get full credit. Right, like that. Okay, now use the remainder theorem. When you use the remainder theorem, you have to use synthetic division to find the remainder and then determine if C is a 0 of this function. And it says, be sure and use synthetic division. Okay, so I'm going to write down all my coefficients. And some of you missed this because you forgot like a little negative or something in here. And I would go ahead and do it. I mean, you lost like a half a point for copying it down wrong, but no big deal. Okay, so try 2. We want to know, is it a 0? So, you know, you got points just for doing your synthetic division, right? Drop this. Whatever this number is, you just try to drop it straight down. Do you see how this one was a 2? So I dropped down a 2. This is a 1, so I dropped down a 1. And that reminds me, some of you think that coefficient is a 0. I had more than one student do that. If you don't see a number, it's a 1. Okay, multiply on the diagonal and then add up and down. So I'm going to do that real quick. That is that 19. Some of you got 18 right there. I think that's 19. That gives me 38, which gives me a remainder of 28. So what's the remainder? It's just 28. Is it a 0? You just had to say no. Okay, why not? Because you got a remainder. That's why. Okay, let's try this one. Again, write down your coefficients. So what is that? A 1, 3, -7, 13, -10. And we're going to see, is -5 a 0? So here we go. Drop down the 1, multiply on the diagonal. That gives me 10. 2 negatives give me a positive. Add, that gives me a -15. That gives me a -2. That gives me a positive 10. And that gives me a remainder of 0. So is that a 0? Yes. Okay, it's a 0 if you get a remainder of 0. You know what that also means? It also means if this is a 0, it means that this, didn't ask you this, but this is good for the future. This is a factor. Because see, look, if you would plug that in there, do you see how you would get 0? So once you find a 0, you've got a factor, which is kind of what this one says. It says use the factor theorem to determine if x minus 1 is a factor. So again, synthetic division. Always use synthetic division. So I'm going to write down all my coefficients. Remember, this is the 4th power. I better have 1, 2, 3, 4, 5 numbers. Okay. And I'm going to try to see if this is a factor. So when you're checking to see if it's a factor, you're going to see what makes that 0. Well, 1. So let's try it. Drop your 1 down. Whatever that number is, drop it straight down. Multiply on the diagonal, add up and down. It gives me -3. Gives me 10, 10, 0. I got a remainder of 0. Okay, so let's look what the question is. Is this a factor? And I would say yes. And it says why or why not. I was looking for the words because the remainder is 0. Somewhere you had to mention the fact that the remainder is 0. And that's it.